Hi, my name is Ian Siegrist, and I have been working under Dr. Ilya Litvak on corrective ferrochromes, specifically on a MATLAB script for the ferrochromes. So the first question is, what are ferrochromes? Ferrochromes are strips of metals that are placed onto NMR probes, which we can see in Figure 1. They help correct the inhomogeneity in a magnetic field by canceling out disruptive orders of the magnetic field and keeping the ones that we want. This is easily done by simply varying the location and dimensions of the shim, and as a result, the accuracy of an NMR spectroscopy reading will increase. This is very useful for the MagLab, especially since the magnets might have minor manufacturing defects or degradation over time, and it's way cheaper to add in these small strips of metals instead of replacing the entire magnet altogether. Onto the MATLAB script itself, we first had to calculate the magnetic field profile based on an equation developed by Holt and Romeo and plotted out certain patterns, as we can see in Figure 2. This helps target the locations of where the ferrochrome should go. Normally, we would have to put infinitesimally thin rings placed around where the field is equal to 0, but since the shims are of finite value, we have to work around this, and we worked around this by finding the position and height of the shims such that the integral of the field is equal to 0. In Figure 3, we can show the locations of the positions and its corresponding heights. It must be based on the calculations we have used, which is very complicated to talk about in 3 minutes. So taking the data that we have gathered, we have placed it into the integrated functions seen in Figure 2 to determine the effect of the shim on other fields, as we can see in Figure 4. In Figure 4, we have a Z3 shim, which shows that the Z1 order is all nullified while Z3 is not for various shim heights and positions. This shows us that we can have certain patterns that are singled out and removed on demand. We can compare this to Figure 5's data, where it assumes that the shims are placed exactly where the shims or where the magnetic field is equal to 0, as if it were an infinitesimally thin ring as mentioned before. As we can see, as the shim heights grow larger, it becomes more unreliable to cancel out the orders. So as a result, my MATLAB code that shows that it can adjust the shim's positions accordingly such that the integral of the magnetic field is always equal to 0, no matter which position or height it is. And as a result of the script, it helps improves research and data values taken at the MagLab, especially for NMR spectroscopy readings. Thank you.